Hi, I'm James the Light Guy, and this is part 3 of the Subaru Legacy Headlight build.
Now that I've cleared the assembly out of the way and laid out all of our materials, we've run into our first complication. The factory harness on the '08 Legacy uses two 3-pin connectors. One for high beam, low beam, and ground, and one for the turn signal and marker bulb. The aftermarket black housings that I received use a single 6-pin connector. We're going to have to cut and splice and come up with a solution to use the factory harness on these new lights. I don't pretend to be an electrical engineer, nor do I actually know how schematics work, but here is a basic idea of what we're going to try and build. We're going to use the factory connectors from the car and add in a DRL circuit for the halo and light strip. But the factory connector from the car for low beam, high beam, and ground will connect to the OEM connector here. The marker, ground, and turn signal connector, we will keep this connector in line because I couldn't get a pigtail with this connector on it. So instead, I found a 7443 pigtail, and it's going to look a little janky, but it will make it so that we don't have to damage or modify the factory harness by running this in line as an adapter from the harness to the adapter to our new harness. Our new harness will have wires running to the marker from the new assembly and the turn signal from the new assembly. We need to add a couple of diodes in between the marker and our DRL system because my colleague wants a very complicated set of conditions to apply to his vehicle. Let's pull that out. Alright, here we have a simple rundown of 8 different states the car can be in and the corresponding states he wants the lights to be in. Like if the vehicle is parked, no lights should be on. But if it is put in gear with no other lights turned on, the DRL strip and halo should be white. So on and so forth until we get to low beam on. Oh, my apologies. When he puts marker on, he originally wanted only the marker light to illuminate, but then changed his mind wanting the marker and the strip to turn on. That's where the diodes come in. When the parking light switch is activated, the DRL circuit is going to lose power. In order to continue having the strip illuminated, we need to draw power from the marker circuit. But we don't want that same power to backfeed to the halo, which is this diode. We also don't want power from the DRL to back power the marker, which is why this diode is here. The diodes we're going to use are these 6 amp diodes. They're a bit excessive for this application, but use what you brought. We have 6 colors of wire for 6 different connections. I know there are 7 lines, but there's a ground wire here and a ground wire here, so that makes 6 different lines. And let's get started. We're going to cut each wire a bit long because it's easier to shorten a wire than it is to stretch one back out. The low beam, high beam circuit is very simple. We're going to take the original factory connector, and all we have to do is modify the high beam connector to work with our new H1 high beam. Since that's just a simple matter of cutting and splicing on a new connector right here at the end, we're going to put that aside for now. Eventually we're going to want to connect the ground wire into our halo and DRL strip, but we can take care of that after we get the next main assembly taken care of. I don't have this connector in yet. That's coming in a couple days. So let's start backward from the marker and turn signal. Here we have our new turn signal connector. Alright, we have our jar of flux. I'm going to use this as an applicator. I'm going to use this to feed in the solder to the joint, and we have our soldering iron warmed up. This is where one of those helping hands would come in handy. And there we go. We have a cleanly soldered joint. Now we have to protect the joint, so we'll grab a piece of shrink wrap from our collection and slide that over the joint. And there we go. Now all we have to do is that for this joint, and knowing that we need to connect the ground for the marker and the turn, we'll cut the ground wire short. I'll see you after I've done that. Alright, now that we have those wires soldered on, we can cut off this part of the marker light harness and splice the ground into this one. Since the marker and turn signal are so close together, I will cut this a bit short and we will connect it about equal distance down from each other. Let's strip the end here and the middle section here and splice them together. Alright, I've made two little cuts here and here, and we're going to just carefully use a blade to dissect that. And then peel it back to expose the core. There we go. Now that we have the core exposed, we can take our second ground wire and wrap it in. Let's flux up the joint. And there we go, another solid joint. Let's get a piece of heat shrink on that to help keep it from getting corroded. There we go. Perfect. Now we just have to remember that our green with white stripe is supposed to be our marker light, and our green is turn signal. Since we were able to save so much of this harness, we may not even need to add an extra color. Let's see how we do. The next thing I want to do is make the split offs for the turn and DRL for the strips here, or strip and halo, excuse me. But before we do that, I want to use a piece of heat shrink to hold all these together here to help strengthen them and keep them from pulling apart. Alright, it would appear that the piece of heat shrink tubing I picked was too small. Let's go up a couple sizes. Try that again. For anyone wondering, I am human. I do make mistakes. And as such, if you notice a mistake I make, feel free to tell me in the comments. I love to learn from my mistakes and not keep making the same ones over and over again. Alright, we've got this piece of heat shrink tubing about up where our previous joint was, and so we can use that to secure everything together. There we go. Now, looking back at our diagram, our strip and halo both need a DRL wire and a turn signal wire. But we're also splitting a marker wire, so both of these will need to be split. And if we're running both of these into the housing to power these, I originally drew it up grounding to the low beam circuit, since the low beam was already going to be in the housing. But if I can keep all three wires bundled together and run them in together, I don't see why we shouldn't try that first. So, we're going to use a yellow, my apologies, we're going to stay green for the turn signal. We're going to switch to blue for the DRL and keep black for the ground. Remembering that we do need to put a diode on the blue wire. I'm going to cut these up and solder on the wires, and I'll see you in a bit. I have soldered in the three wires, and I added an extra piece of heat shrink tubing to hold those wires together. I'm going to put one more piece of tubing to hold these joints together, and then you can see we have a Y split for our external marker and turn signal, and our internal turn signal, DRL, and ground. Let's put on another piece of heat shrink tubing here. Let's go with a fairly large diameter piece to try and get over this. Well, that's not going to be large enough. That might be a bit big, but we'll see. It does shrink down. It is heat shrink tubing. There we go. We'll leave this end trimmed up. I'll cut these to match length, and these will connect to our new connector when that comes in. We'll need to add a diode to this DRL wire, and then we'll need to find a grommet. Maybe we'll get the grommet first and find where we want to put that. I'll be back in a moment. I found this grommet which would be perfect for this, so we'll use this. But just remember that our strip doesn't have a connector on it. So making installation and removal of this harness will be rather difficult if I hardwire it in. Luckily, I have some of these 3-pin connectors. We'll just have to try not to confuse ourselves even more by going from black and green and blue to red and green and white to red and yellow and black. Let's see if I don't screw this up. First, let's get the grommet on and pushed up out of the way. Figure out which direction these wires need to go in from. Go. Let's see what order we have these going in. We have blue, then black, blue, then green, then black. Perfect. Eventually we'll get a little bit of RTV or silicone and seal those up. At the end of this and hit the flux. Let's clean that off. And move the flux out of the way for now. Alright. Now before we put on the connector, we need our diode. And before we put on the diode, we're going to want to put on a piece of heat shrink. Let's go with a slightly larger size. That way if my joint gets too big, we can still shrink down over it. I'm going to leave all of these wires long. They're going to be hidden inside the housing. And since I haven't set up everything, I don't know how short to make them. Alright, now normally I double check my polarities on this, but a simple rhyme I have used, excuse me, a simple rhyme I have used in the past to try not to make the mistake is starting from the center of the diode, white is toward the light. So, since I want electricity to go that way but not this way, it will head toward the light. We have our heat shrink on there. I'm going to crop this down a bit on this side. There we go. And start winding this up. That doesn't look too bad. Let's get our flux on it and solder the joint. too much flux right there. Good. Again, a set of soldering helping hands would come in very handy right now. See how close I can actually get to burning myself, shall I? Thing is wobbling all over the place. Clean that back up. There we go. Well, that wasn't pretty at first, but I managed to clean it up decently. We'll wait for that to cool down a little bit before we put the heat shrink tubing on, and we'll move on to the next step.